my name is Raimo Niskanen with the Erlang OTP team, and I'm currently working on the new socket API. It is a work in progress that was experimental since OTP 2023, and will be not experimental, not experimental in OTP 24. We already have some power users. Actually, I will try to give a short background, a tour around the API, try to connect the dots between the functions, something about the progress and plans. So today, GenTCP and friends, they have a bunch of helper modules working for them. There's one per address family, actually, and also some common helper functions. Then all comes down to prim inet and the inet driver and down to the platform's APIs. The inet driver, since it's a driver base, kind of like a process in that it has to be scheduled to run. And apparently this API was not enough because people, even ourselves, are using prim inet directly because we have to. So we need a new low-level API. It just consists of the API module, the NIF, and the socket API below. So it's a call straight down without scheduling, hopefully, except when there has to be scheduling, when you have to wait. On this, we will build adapters, new modules that adapt the old GenTCP legacy API to the socket API instead. These will need processes because they need to handle, for instance, receive active mode, and TCP will have to handle the complex packaging and so on. But now we may use the socket API. It is just a thin layer on the POSIX sockets, the Berkeley sockets. They have now been possible to do this API thanks to the NIFs and mostly the dirty NIFs, the scheduled NIFs that's needed for a few specific things, and also the possibility to select, to customize a select message. We also use maps heavily for C structs. Whenever there's a C struct, we try to use a map. The socket module handles socket things, so this is the POSIX stuff. The net module handles not socket things. We here have, for instance, get your own host name, and we have resolver functions. So here we had to decide on, should this be the new resolver or should this be a component in the old resolver? You have a whole resolver systems in inet today. We also have some own stuff here that's not POSIX. I will come to that. The socket open function is really called a POSIX socket, with the difference that we can use symbolic names for domain type and for protocol. Protocol is interesting because nowadays it's an open-ended set that we read up from the operating system when the NIF library loads. To use any of these strange protocols, you probably need some special capabilities in Linux or root in other operating systems. We may also use integers for domain type and protocol. You have to look these up carefully in the running system header files to get it right. The options is a map, as you see. Among things, there's a debugger. You can also set the network namespace in Linux here. The return socket is an opaque type containing a NIF resource, as expected. Regarding the error reason, we can say that the POSIX errors nowadays will come from the POSIX layer. There's the sockets. We will not invent POSIX errors, so you can tell directly if an error comes from the platform or from us. We have our own atoms. Binding an address to a socket is actually an optional operation. There is a paper from the Heroku guys called Sockets in a Bind, where they explain when it's good to not bind. An interesting read, really. The socket address has just got one mandatory field, and that is the family. And then for the inet family, we have two other fields. One of the other things, an IPv4 address. For the local address family, that is the Unix domain sockets, you have a path, a file system path. That's on Linux has a special variant that is not a file system path, but that's another thing. We here see a few other error of our own error reasons. The invalid one, we are thinking about expanding that one to a tuple so we can tell what is invalid also, not just that something was invalid. Creating a connection, you first have to put a listening socket in listening mode. The backlog size here should for sctp probably be a boolean. Accept and connect creates the connection. We here have a timeout argument that is not POSIX. That is our own extension. The timeout argument may cause a special select return value. Or rather, if you use the timeout argument no wait, you may get a select return value. That is, if you had to wait, or you could not wait, then you get the select return value. And if you get the select return value, it contains a select info. The select info contains a select handle, and the select handle comes later in the select message when it's worth trying again. Timeout in itself may be a timeout in milliseconds or infinity. The default is infinity, and when I say default, I mean that all functions comes in a variant without a timeout argument, and then it's infinity that is the default. So here we have a simple timeout. We set a timeout for 5 seconds and may get an error timeout return. With this construct, we cannot do something while waiting. We cannot receive a message. We cannot regret that we are waiting. We are stuck here for 5 seconds. Instead, if we use no wait argument, we get a non-blocking connect. It will not return error timeout, but it might return the select return. That is, if we would have to wait, if we do not have an immediate connection. And we get the select handle that we receive in a select message, as I said. When we receive the select message, we do a follow-up, in this case, connect arity 1. That is special for connect, for instance, for accept and send. We just repeat the operation. Now we can do something before going to receive. We can do something when we get a message. During receive, we can set up an own timer, delayed message as a timeout, and we can use receive after to get the simple timeout on the previous page. A refinement on this is to use a reference as the no wait argument instead. Then that reference will be contained in the select info, and it will be the same reference in the select message, meaning we have a make reference with a receive and receive the reference we made. This enables a receive optimization that will avoid scanning the whole message queue. The select info looks a bit redundant here, but that one is needed to regret waiting. You can cancel a select operation. This is an extension of ours, so there is no POSIX error on this one. A process that dies also cancels a select operation. Under the hood of a no-wait connect is the NIF gets a return value from the operating system indicating that the operation could not complete immediately. So the NIF tells the VM that when this file descriptor gets writable, you should send this PID that message. And the VM puts the selector, the file descriptor, in the poll set, and when it falls out, it sends the message to the PID. And the process goes on with calling the follow-up function that for connect on Linux often do a get sock opt. This is a different way of platform. Asynchronous connect is a nightmare. Here are more API functions with timeouts. These can be executed in parallel. The connect cannot be, but these can. They have process queues to accomplish that. A special one here is the send that has got another select info that contains REST data. That is, you may succeed in sending some bytes the operating system informs that we could send 3 bytes and the rest is not sent. So we return the bytes that are not sent, and we should use these bytes in the next send operation when a select message has arrived. We also see a flags field for almost all functions, and we find a message instead of data here on receive message and send message. This is because a message is not just data. A message is the data that might be an IO vector, or is an IO vector. I think it can be a binary too. And it contains the address, at least for UDP sockets, because then you don't have a connection. So you have to talk about an address for the message too. You also have flags for received messages. You can get, for instance, a message flag sending for sctp saying this was the end of a record. Here we also have the control messages, also known as ancillary data. That leads us to another record or map, really. You can, for a message, say that in the symbolic notation, with the symbolics, that the IP type of service should be low delay. You may also give a binary for this value if you know what it should be on your platform. And you can also use a raw format with integers for level and type and data. The message flags are optional arguments to receive and send operation, and also return from receive message operation concerning the message. For instance, here's the end of record flag. You have to consult the platform documentation to find out what these mean. There's no such thing in the current GenTCP API. One more thing to check besides the platform documentation is that we have support functions. One is called supports, and the other is supported, that reports if a flag is supported or not in 2 different ways. The support function returns a list of features and if they are supported or not. This one returns all the other ones contained there. You can also ask for a list of message flags and see which are supported, or a list of all known protocols. This is the list that is enumerated by getProtoEnt when the NIF library is loaded. You can also list all known socket options, known and which are supported. The isSupported function is often more useful in code because it simply replies with a boolean if something is supported. For instance, is the message flag don't root supported on this platform? Or is the protocol sctp supported? An interesting nuance difference here. The protocol sctp supported means we know the protocol number of sctp, while is sctp supported means have we compiled against sctp header files and linked against the library. That is, should we suspect that sctp is working. We can also ask for a specific socket option, which brings us to the socket options. A socket option is a 2-tuple, level and name. These are atoms. The return value from getopt. No, I'm talking about setup, sorry. The argument value that is allowed depends on which option it is. Some are integers, some are booleans, and yet again, some are maps when the operating system wants a C structure here. We also have our own level, the OTP level, that, for instance, have a debug boolean, debug flag, receive buffer size, the controlling process and stuff. There's also a native setup function that takes integers for level and name that you will have to look up in the system headers. And the type of the value decides how this value should be encoded for the operating system. The getopt return value also depends on which option you are asking for. For the getopt native function, the type is a specification for how to interpret the platform's value. The usual ones, integer, boolean, binary, but we also have, you can give a buffer to getopt which actually works like a value result argument. You give it a buffer and you get another buffer back, so you get another binary back, actually used for some options. Disconnecting a socket. We have the normal POSIX function shutdown, and we have the close function. It is a known problem for closing non-blocking sockets that the socket option linger does not work, because it is a contradiction in that linger means wait for data to get sent, while non-blocking means return immediately. So this combination does not work, period. The INET driver have never succeeded to get around this, so it doesn't close correctly. We would have to implement a thread pool and some other disgusting stuff to get that working. While a NIF can simply set the socket in blocking and use a dirty NIF to do the close. So that one will be scheduled and we get a message when it's done. We have some more non-POSIX features. We have the info function that returns some information about the socket, the type, controlling process, counters and statistics, etc. We have a function that lists all sockets. We have one that lists some sockets according to some predefined filters or an own filter function, filter fun. These ones, we also have a number of sockets. These ones use the socket registry, which is a name process that the NIF sends open and close events to keep count of the sockets. Since it's a process with a no-flow control on the messaging, it may choke on some extreme systems. Therefore, you can disable this, but by setting use registry to false. There's also a start flag for the emulator for this, and you can set per socket when you open it also, if you have special needs. So, how are we doing? Well, the API will be ready for OTP24, for Unix that is. Of course, some risk for having to change some small details. Socket and net are almost done. We have to decide on this resolver issue I mentioned. We will now focus on send file to get that working. Here we had to solve the problem of passing file handles atomically between NIFs without leaking file handles or leaking other things. We will also focus on the distribution and on SSL and SSL distribution. The distribution should use socket directly with the distribution process. SSL might first have to start using the GenTCP adapters instead of using socket directly, but we will fix that eventually. Windows, sorry to say, is not really started. It's quite different. We have to decide on if we should try a WinSock and do a socket module that behaves the same on Windows. People have tried before and failed, so maybe we should create a different NIF and have the platform independence on the GenTCP level instead. Or maybe on other APIs that we're thinking about. GenStream is a thing we think about, a kind of data server callback module. We will also look at what Elixir has got in this area, or maybe even Java streams, things like that. See what others have done here, simply. The GenTCP adapter is mostly done. We are trying it out now. It's selectable now with a kernel flag, INET backend socket, or INET is the old behavior. There is also a socket option that has to be first in the socket option list. The other adapters is not done yet. They should be simpler. GenTCP had a huge problem with unpacking complex packet formats. We also need some small API extensions because we ourselves use prim INET for some applications, mainly to get the file descriptor or to monitor a socket. We assume that the socket is supported and can be monitored. So we probably should get this into GenTCP and make it transparent to what backend we're using. Then we hope that socket and its adapters will be default for OTP25, hopefully. Then we'll see what the future will hold. So, thank you for your attention.
Great. It was very detailed, very interesting presentation. Awesome. Thank you, Raimo. We
Hope
have a
it
number
was
of
not
questions.
too fast. Oh, really?
No, no. We are just in time. We still have a few minutes for questions. I will ask first Fred if he can ask his question, please. Fred?
Oh.
Fred, can you? We don't hear him, so I'm gonna read it out loud. You referred to GenTCP and GenUDP as legacy interface. Is this because they are going to be deprecated, or you just meant that they are older APIs?
Sorry, bad wording on mine. I didn't mean legacy as in deprecated. I mean the older APIs, the established APIs. Sorry about that.
Okay, good. But
I didn't mean to scare anybody.
Okay, thank you. This clarifies. Then I will ask maybe Joachim. Would you like to ask your question? I have difficulties unmuting him as well, so let me read this question. Pros and cons with the new socket API compared with the legacy Ditto.
Well, pros is of course that you get all the features of the POSIX, the Berkeley socket API, all the message flag, all the stuff. It's easier to not bind a socket. You can check all the flags. You can use send message. The GenTCP API has got an impedance mismatch with the socket API. You cannot do all the things you want to do. So that's the pros. Cons is that there are more functions to call. And since there are more functions to call, or rather since they are so thin layer, you will get the platform's quirks to deal with. Sometimes you get one control message on FreeBSD and another on Linux for the same thing. So it's a more transparent layer which shows the operating system's quirks, which may be a con or a pro.